on 6-8, this investigation with simplifying rational expressions, we kind of need to remember a few things about fractions. So when I'm adding or subtracting fractions, and we're not going to use that today so much, we are going to use it a little bit later. So to add or subtract fractions, what do you have to have? Common denominator. And we are not dealing with that much today. So as I was saying, we're not going to do a lot of that today. You're not going to have to worry about that, but I do want you to remember that as we move forward. Multiplying fractions is actually one of the easier things to do with fractions. So if I have A over B times C over D, how do I do that? What do I do? Straight across the top, straight across the bottom. So A times C over B times D. The one that a lot of people don't remember or vaguely remember is dividing fractions. Anybody remember that? How to divide fractions? Some people learned it as cross multiplying. That can get confusing because sometimes when solving ratios, other teachers refer to that as cross multiplying, so that can get a little tricky. So if I have A over B divided by C over D, what I'm actually going to do is multiply by the reciprocal. So this would end up being A over B times D over C. So I just took this second fraction, flipped it over, and now I'm multiplying. So then I just multiply straight across the top and straight across the bottom. And as it was mentioned earlier, some people refer to that as cross multiplying, so they go A times D, so for the AD, and then B times C for the BC. But as I said, that can confuse some people because when you're solving proportions, you cross multiply, and some people just get confused on it. So I prefer to teach it as you flip the second fraction over and multiply. Okay, so what I want you guys to do, and we will go over it in just a few minutes, is turn to your group members or somebody around you, and for some of you, you're all over the place, and read through number 1 and answer the questions on number 1, and we'll talk about that, and then I'll have you move to number 2. All right, so on the 16x over 16x equals 1, yes, he is correct on that. X can't be 0 because you cannot divide by 0. Now, if I have x minus 3 over x minus 3, does that equal 1? Yes, it does. Same thing, divided by itself, that's going to equal 1. However, what can x not be? 3, because 3 would make the denominator 0, so we have to watch out for that. So x can't be 3. Is the following equation true? Z over z times x over y equals x over y. Is that true? Why is that true? Exactly. So one of the things I want you guys to remember when you're crossing those pairs of things out, it's not that they just disappear, they divide out to give you 1. And the reason that that's helpful for us is because 1 times anything doesn't change it. You can multiply anything by 1 and you get the same thing. So we have x over y equaling x over y, which is true. Now, does that work for every value of x and y? What's the restriction? What's my restriction there? Z can't be 0. And what else can't be 0? Y can't be 0. Can x be 0? Yes, it can. Because it's okay to divide x, or to divide 0 by something, but you can't divide by 0. We'll talk about it more later. Okay, so looking at number 2, let's take the chatter back down. X squared divided by x squared, what does that give you? 1. Something divided by itself. So, I try to stay away from saying that things cancel out because they don't just disappear, they divide out to 1. So this is 1, but what can't x be? 0. On part B, since we're just multiplying here, those x's can divide out, those x's can divide out. What am I left with? X over 3. Do I have any restrictions on what x can be? Not on this one. X can be 0 because we can have it in the numerator. 0 divided by 3.
Those x's down there.
If x is down here?
No, those x's down there, yeah. The ones that cancel out.
Oh, that's an excellent point. So, before these divided out, if I put in 0 for x, that would cause me a problem. William. That would cause a problem, so you are right on that one. X can't be 0. On my final answer, the x over 3, then x can be 0, but not over here. That's a very good point. Alrighty. On part C, what can I do with that?
You got x plus 5 equals 9 over x minus 1.
Yep. So my x minus 2 over x minus 2, that divides out, and I am left with x plus 5 over x minus 1. So, we're going to talk about this shortly. Okay, so what can't it be? What can't x be? 1. So x can't be 1. If we look at our original problem, it also can't be 2. 2 does not cause a problem in our simplified equation, though. Okay, so one thing we're going to talk about in just a little bit is why we're not canceling out these x's as well, but we'll talk about that shortly. What about D? What is that? What? 9x over 9x, which would be 1. And what can't x be? 0. My formatting on this got a little screwed up. This was supposed to be on the other column over here, but what happens on part E? What's dividing out there? So I'm left with just HK. And any restrictions?
0.
H can't be 0. Alright, over to F. What can I do with that one? Anything dividing out on that one? M plus 6, because I have exactly the same thing on the top and the bottom. So, I want to come back, and we're going to talk about this down here as well, but I do want to start to talk about it. We can't simplify these any further because once we divide those out, is the top being written as a product or a sum? As a sum. So, once we're adding and subtracting and we're not multiplying like here, we're multiplying factors. And once we divide those out, we're not left with very much in terms of what we can divide out because when we're adding and subtracting, those rules don't apply anymore. So the canceling out or dividing out 1 doesn't work anymore. And we'll talk about this down here when we get there. So on this one, I'm going to remind you that n minus 2 squared is the same as n minus 2 times n minus 2. Not that you have to write it out like this, but this is a helpful visual for people. So, a couple things can happen to simplify this one. What happens to one pair of the n minus 2? That will divide out. Is there more that I can do to simplify this? I have the 6 times n minus 2 divided by 3. Is there more simplification I can do? Yeah, and what is 6 divided by 3? So does that go on the top or the bottom of the fraction? On the top. So that's going to equal 2 times n minus 2. So one of the tricks for that, if you're trying to figure out if it's supposed to be on the top or the bottom of the fraction, if the bigger number is on the top, it's going to be on the top of the fraction. If the bigger number is on the bottom, and you reduce it, it's going to stay on the bottom. All right, what about h? Yep. Now this is where it's really important to remember that that doesn't just disappear, it divides out to 1, because what do I have to do with that 1?
It's like, there ends up being a 1 on top and you just flip them? Or do you not flip them?
You don't even have to flip them. So the 4x minus 1 is on the bottom, right?
Yeah.
And it has to stay there. So I have to put something as a placeholder for a numerator. I can't just have nothing. So that's where that 1 is going to go. So it's going to be 1 over 4x minus 1.
Are we still mentioning if something can't be a variable, can't be a number?
Oh yes,
Oh,
you're right. I've forgotten that. So on F, if we go back up here, what can M not be? Can't be negative 6 because of that original problem. It also can't be what? What would make the denominator 0 here? Negative 1/3. What about G? What can N not be? 2. And on H, what can X not be? 1/4. Also, if we look at that, technically that one can't be 3 over 2 either. Okay, so on number 3, some of you got there, some of you didn't. One of the things you want to be careful about, it says pick a few values to test this. And the first value that I picked was 4 plus 1 over 1, which happens to give me 5 over 1, which is 5. That is true for this. But if I put in a different value, so 4 plus 2 over 2, I end up getting 6 over 2, which is 3. So when I look at a problem like this, these cannot just divide out. If I am adding something and I'm not multiplying anything on top anymore, I can't divide those out. The rules of multiplication and division work with multiplication and division. The rules with addition and subtraction don't work quite as well with it. And if you think about what you know about, like, if I were to multiply x squared and x, that would give me x to the third. I can do that. But if I try to add x squared and x, I can't do that because they're not like terms. It's kind of a similar problem. So when can I simplify by crossing things out, and when can I not?
When it's multiplication or division.
Yep. So when it's a product or a quotient for that matter. So basically when it's factored. So when things are factored, otherwise known as written as a product, you can divide out to 1. And that's both the top and the bottom have to be in factored form. When they are written in standard form or written as a sum, you cannot do that. So what that brings us to is kind of what we did in the warm-up, and what we're going to do we're going to do a practice problem on the back, and then I'm going to set you guys to work. Anybody still writing this? So if you flip your paper over, if you haven't already. A couple things to note. I cannot just cancel out these x's because I have x's on the top and the bottom. This is written as a sum or in standard form. This is also written as a sum or in standard form. So what I have to do with both of those is factor them. So I'm going to go ahead and use the box and diamond method because that's what a lot of people are more comfortable with. If you use the algebraic grouping method, which is taught more in the intermediate algebra class, then use that. Don't feel like you have to use box and diamond if you don't want to. So we start with I'm just doing the top right now, 2x squared and negative 10. I multiply those to give me the top number, so negative 20x squared, and then I put my middle term, which is that negative x, on the bottom. So then I need to figure out what my side numbers are. So if I don't know that off the top of my head, then I'm going to factor 20. So I always start with 1 and 20. 20 divided by 2 is 10. 20 divided by 3 is not a whole number, so I'm not going to bother writing it. 20 divided by 4 is 5. And then if I went on to 5, I would get 5 and 4, which I already have that pair, and that's how I know I have all my factors. If the top is negative, what do I know about my about my side numbers? One of them has to be negative. So if my bottom number is negative, is it going to be the bigger number or the smaller number that's negative? Larger number. So in those pairs, which pair of those adds up to be negative x, or negative 1? 4 and negative 5. So if I look at a column or a row here, you want to be careful about what you can factor out in this. So I can't take a 2 out down here because 5 is not divisible by 2. So I'm going to take this 2x out this side because I can divide both 2x squared and 4x by 2x. 2x times x gives me 2x squared. X times negative 5 gives me the 5x. 2x times 2 gives me 4x. So my factored form on the top is x plus 2 times 2x minus 5. And now I have to do the same thing for the bottom. And as I said before, on some of these you have to do this for both the top and the bottom. On other ones there are some tricks or special forms and other things to do. Always remember to check for a greatest common factor, stuff like that. So now I'm going to factor the bottom part over here. So 3x squared and 2. Multiply those together to give me 6x squared. My bottom number is 7x. Interestingly enough, when this type of thing happens, the one thing that people often forget is that 1 and 6. They'll often skip the factor that has the 1 in that number, and in this case, that's the one we're going to use. So the 1x and the 6x that add up to give us 7x. no negatives to worry about on the bottom. So we got 1x and 6x. Again, we have to be careful because we can't take the 3x out here. We have to take it out this side, because both 3x squared and 6x are divisible by 3x. So 3x times x gives me 3x squared. 3x times 1 gives me 1x. And 3x times 2 gives me 6x. And then it's always good to double check that 1 times 2 does actually give you 2, so you know you have that factored right. So then when I write this up here, it's going to be x plus 2 times 3x plus 1. And then what can I divide out? Once I have both of those in factored form, written as a product, the x plus 2's divide out to 1. So what I'm left with is 2x minus 5 over 3x plus 1. And because these are now written as a sum or in standard form, I can't divide anything else out. This is as far as I can go. So that is my answer. So some of the things to look for as you're looking at these problems are factoring out a greatest common factor, checking for perfect square trinomials like the x plus 2 squared kind of thing, and then the difference of squares might also help you out. So you have 3 more problems on this back side of the first worksheet, and then I'll pass out your homework worksheet, and that is it for this lesson.